All right, in this video, we're going to talk about functional groups and naming. And we're going to see a lot of the functional groups, and we're going to learn how to incorporate them into the names of these alkanes, alkenes, and alkynes, and try to determine a correct IUPAC name. So let's take a look here at our first example. We have 1, 2, 3, 4, 5 carbons. Now, no matter how we count these carbons, we need to do it in one contiguous chain. And notice we have a double bond here. We have an ene. So we need to have the longest chain including this double bond. So we can start here, 1, 2, 3, 4. Okay, 1, 2, 3, 4. All right, nothing longer. And that's about it. From this side, 1, 2, 3. All right, well, that doesn't count because it doesn't have the double bond. 1, 2, 3, 4. So it looks like we're going to have, in this case, a backbone with 4 carbons. We know that it's going to be bute, and we know then we need the ene. All right, and now we need to know, is it going to be 1, 2, 3, 4, or is it going to be 1, 2, 3, 4? All right, well, let me erase both of those, and let's try to determine. Well, the double bond is going to dictate and want to have the lowest number. So if we count off from here, 1, 2, 3, 4, I think we have it. The other way, it's going to be on the third carbon. All right, so we can either show this here or here. Nope, not dash 1 dash. Or actually, that's what I want, dash 1 dash. So this is going to tell us that the ene is on the 1. You could also have bute ene. I think your book gives you that. Let me just erase that, because we're going to put it in front of the prefix. Now, 1, 2, 3, 4. So we have our butene, 1 butene, and we need then this methyl group. We have a single carbon, that's a methyl, and it's on the third carbon. So 3 methyl, 1 butene. Now sometimes you'll see the 1 being understood removed from the name altogether, and that's fine. If you include it, it never hurts to be safer than sorry. All right, so there's our first one, 3 methyl, 1 butene. Let's take a look here. What do we notice? We have all single bonds. So this is going to be an ane. We have an OH here, hydroxyl group. This is going to be an alcohol. All right, and we need the alcohol in the backbone chain, not as part of it, but the carbon that it's attached to as part of it. So 1, 2, 3, well, that doesn't work because the alcohol is not on the carbon in the backbone chain. 1, 2, 3, 4. All right, and then counting from the other way, 1, 2, 3, 4. Well, the alcohol is going to need to be the lowest number. So if we counted from here, 1, 2, 3, 4, it'd be on the third carbon. If we count from the right to left, 1, 2, 3, 4, that's going to give us the lowest number. So let me write that, 1, 2, 3, 4. Now, so we have a backbone of 4 carbons. Bute, they're all singly bound, and all right, and we know alcohols have the ending -ol, so this is going to be butanol. The -ol is on carbon 2, and we have another methyl group, and this time it's on 3. All right, 3 methyl 2 butanol. The -ol is on the 2. 4 carbons, all singly bound, and we have a methyl group on the 3. All right, let's look at our next example. All right, well, what do we have here? We have an amine group on this carbon right here. All right, so we can count 1, 2, 3, 4. 1, 2, 3, 4. So I think we're going to go from left to right because the amine wants to have the lowest number carbon it's attached to. So we'll count from left to right. One of the numbered carbons is the one that has the amine, so that's very good. And we have this methyl group again on this second carbon here. Well, with amines, we know that they end in amine. All right. We know we have but and single bonds, so butamine. All right, butanamine. And the amine is on the second carbon. And now we have this methyl group again, and it's on the second carbon. 2 methyl, methyl on 2, 2 butan, 4 carbons. The second one has the amine, and they're all single bonds. 2 methyl, 2 butamine. All right, looking at this next example, we see yet still another chain of 4. We have that methyl group coming off one of these, but now we see a carbonyl. All right, and the carbonyl doesn't have anything else with it, so this is just a lone carbonyl. And we know then the lone carbonyl could either be on a terminal carbon, that would be an end, and this is an end, this is an end, so it's neither of those, and that would be an aldehyde. On an interior one, it's a ketone. So we have a ketone here, and we know that this molecule is going to end in -one. All right, well, we need to incorporate the carbon that it's attached to. So 1, 2, 3, 4, 1, 2, 3, 4. Obviously, we want the lowest number, so we're going to label from right to left. That is going to be, okay, 4 carbons, butanone, single bonds, 4 carbons, single bonds, and -one on number 2. So 2-butanone, and we have this methyl group that keeps on coming into all these problems on 3-methyl 2-butanone. All right, let's scroll, scrolling the wrong way. Scroll down. Now we have another carbonyl in this example, and it's on a terminal carbon. So this is going to be an aldehyde. And we know that aldehydes end in -al, not all like alcohol, but -al. So we're going to put an -al here so we know our ending. We need to count the carbons in the backbone that include the carbon that the carbonyl is part of. So we can go 1, 2, 3, 4, and it could be the fourth carbon, or it could be 1, 2, 3, 4, and be the first carbon. So we're going to label from the first to give us the lowest number for the aldehyde. All right, this is a chain of 4, butanal. Now, it's on the first carbon, but it has to be on an end. So you could put a 1 here, but it needs to be on the end. And you're probably just seeing that. I'm going to erase it, because we don't need the 1 there. It's understood. It has to be on an end. And since it's taking precedent, it's going to dictate what is the number 1. All right, so we don't need to put the 1 in there. However, we still have this methyl group, and it is going to be on the third carbon in this case. So we have 3-methyl butanal. All right, 3-methyl butanal. So you can see that picking the right length chain that includes the carbon with the functional group is key to much of these. So here we go. Here's another example. We have a carbonyl, but wait, that's not all. We have a carbonyl, and then we have this OH. This is its own, this isn't a carbonyl and an alcohol. This is one whole functional group. It is the acid, a carboxylic acid. All right, and the name's going to end in acid. We need to let you know it's an acid. So we count off 1, 2, 3, 4. It's going to be either 1 or 4. Obviously, we want this to be 1. Now I want you to see something here. On acids, 1, 2, 3, there's already 3 bonds here. This can't be on an interior carbon. You can't have an acidic group somewhere in the middle. It has to be on the end. So just like the butanal, this has to be on the end, and we're not going to see a 1 butanoic acid. That's what this would be. But and oic, upper pertaining to. So a acid pertaining to or attached to 4 carbons with single bonds between them. And then we have this methyl group that's in all of these on the 3rd carbon. So 3-methyl butanoic acid. All right, let's look at this next one. Now we have this seemingly carbonyl, but wait, we have what looks like an amine. An amine and a carbonyl are a special functional group. It's an amide. All right, so this whole thing right here is an amide. All right, and we're going to end it with amide. We need to have it be part of the count. So this is going to be 1, 2, 3, 4. 1, 2, 3, 4. Some of you might say, well, what about this carbon here? Well, it breaks at the end. So we have to count through the end in order to count carbons. And if you're not counting carbons, you're not counting carbons. So we can't count through the end. So the amide, we're going to count from here. You might say 1, 2, 3, 4. Well, no, we want the amide to have the lowest number. So this is going to be a 1. Okay. And just like with the acid, we have 1, 2, 3 bonds. All right, so this can't be just in the center anywhere. Okay, it always needs to be on an end, otherwise you have 5 bonds on carbon. All right, so this amide here on number 1, and that's going to be understood because it can't be anything but on number 1. And we have a methyl group here. Now let me change some colors so we can see these. We have a methyl group here, and we have that same methyl group we've been seeing in all of these right there. Okay, so we have 2 methyls. Remember, it would be dimethyl. We have the 1 methyl off of the 3rd carbon, and we have the other one attached to the N. Okay, so in writing this, we write N, and I'll color code it, N3 dimethyl. Oh, I left no space whatsoever. Let me go to a hard eraser here for a second. All right, N3 dimethyl but, and because we have single bonds amide. So N3 dimethyl butanamide. All right. So sorry about the lack of space there and having to erase part of it, but hopefully you saw through the process what we were talking about. All right, this one we see the carbonyl group, but we have a single bond O in the with R groups on either side. This is an ester. Okay, this is an ester, and we count off 1, 2, 3, 4 from the ester in the direction away from the oxygen. We can't count through because the oxygen's there. And on the other side of the ester, so we have on this side with the functional group, we have 4 carbons. Okay, so we're going to see the but come in here. Ester, they end with O8. So we're going to see but and O8. So we know it's an ester. On the major side is 4 carbons, single bonds. All right. Oh, yep. And we have that vial methyl group that we've been seeing in all of them. Okay. And on the other side of the ester, we have an ethyl group. Okay, so that's going to come in first. All right, we want to know what is on the other side of the ester. So we have an ethyl butonate, meaning that the ethyl is on this side, the 2 carbons wide, and then the backbone with the O8 on it being 4 carbons. And then we have the methyl group off of the third, so it's going to be ethyl 3 methyl butonate. All right, almost done. I know you're probably wanting to tear your hair out. Believe me, I am too. Not your hair, my own. All right, so here we see an N between 2 methyl groups. This is an amine, and we know it ends in amine. But if you don't have a particular long chain here, we just talk about what's on either side of the amine. Here we have methyl groups on either side, dimethylamine. And finally, this last one, an oxygen singly bound to 2 R groups. This is an ether, okay? And it's going to end with the word ether. And on one side we have a methyl. On the other side we have an ethyl. And that's exactly how we do this. Just make sure we have it in alphabetical order. Ethyl, methyl, ether. So it tells us on one side we have ethyl and on the other side we have methyl. And even if you flip them over, it doesn't matter because you could mirror image it and it'll still be ethyl methyl ether or ethyl methyl ether. Well, hopefully this helps.